Okay, hi everyone. I'm Adwith from Hopkins Robotics Team 12377 in New Haven, Connecticut. And in this video, I want to introduce you guys to CAD software in Fusion 360. Um, if you don't have any experience with CAD, it stands for Computer Aided Design, and it basically allows you to build your robot before building it for real. I'm doing this in the context of the FTC competition, so you can plan out your robot before wasting time and money uh, building prototypes physically. So Fusion 360 is a relatively new cloud-based software, which means that you can collaborate online with others, just like on Google Docs. It's a super useful skill for a robotics team to have, and the software is really easy to learn, as you'll see in this video. So I'm just going to show you the basics, why we CAD in the first place, basically the advantages, and then I'll show you how to import and assemble Tetrix parts in Fusion 360 for your robot's design. If you have moving parts, you can even animate them in the software and make sure that all your moving components of your robot do their job and don't intersect with each other and mess up your design. So basically you can troubleshoot in the software before you even start building and putting the parts list together. So this allows you to save a lot of time and money on your robot by getting all the troubleshooting issues out of the way. And also, if you're an FTC team, then judges at qualifier competitions and state competitions really like to see teams that CAD their designs. Shows forethought and a lot of dedication, and it'll win you points for Inspire or Think Awards. It's also really simple to learn, so it's quite worth it. And so let's move on. Let's actually get started. First, you have to actually download Fusion 360. It's a free software for students. I'll link this in the description below. You just have to create an account, register, and download. It's very simple, very quick. Once you've downloaded it, you can start assembling these Tetrix parts. I'm using Tetrix in this example because it's pretty popular in the FTC community and super easy to build. So this is Fusion 360. I've already downloaded it. And before we get started, we have to actually download the STL files that we're going to be using for our robot. STL files are basically 3D CAD files that you can import, and it's like virtual parts. So again, I'll link this in the description below. It's a GrabCAD site where you can download all sorts of Tetrix parts. You do have to create a GrabCAD account, but that's free. Very quick to do. So I'll just download the files. It'll show up as a zip. If I go into, once it finishes downloading, let's wait a little bit. Alright, here we go. We can go into Finder, unzip this file, unzip it, open that, let's see, Tetrix Kit FTC, and we've all of these STP files, are basically equivalent to STL files. So how do I get these in? Here we go. So when you open Fusion 360, you'll see this screen without the skateboard, obviously. It'll be blank. You want to go to the top left corner where it says Show Data Panel. This is where you can keep all of the references, all the files that you'll reference in your CAD project. You want to open my first project. That'll be default, and you can upload STP files, STL files. So I'm going to select the files that I just downloaded. Let's find it in downloads. Official Tetrix parts, I think. Tetrix. Bring it up to Tetrix Kit FTC. I'm just going to select all of these. It's a lot of parts, so everything you'll need. You just hit open and upload, and it'll all start uploading. Yeah, there you go. And it'll take a while because it's a lot of stuff. But it should be done in like 5 to 10 minutes. Then you can get started in assembling, like start building your robot. Great. Okay, so all right. So I've downloaded all of the STL files and renamed them so it's easier to access. Here they are. I put them in nice, neat folders so I can easily access them. And now you can do that too. Doesn't take that much time. Just rename them. Yeah. So you're gonna be open with an untitled project, and you want to name it by Command S or Control S. Save it, and let's name it. Let's see, CAD tutorial. Save. Now I can start inserting these STL files that I've downloaded. So these are basic Tetrix structure. The way we get them into the file that we have open, we right click, insert into current design, and there we go. There's a default move copy selection on here, so I'll just rotate a little bit, 90 degrees, so it's flat. And that's kind of boring, so I'm going to have another one. Same thing again, insert into current design. Yeah, I will move this one over. Hit OK. And now I have two pieces of channel, but they're no good just sitting like that. So I'm going to join them. In a way one might assemble a chassis. So yeah, let's see. How do I join them? Most of the functions you'll be using in making a virtual robot is under this Assemble tab. So you go to Assemble, Joint. Then you're allowed to select two faces or two components of the project that you want to combine. You want to make go together. So I want this circle over here to overlap this circle over here. So the way I do that, I just take this circle guide there and there, and just like that, they intersect. But that's C channel doesn't intersect like that, so I'll flip it over and rotate it 90 degrees, just like that. So it looks nice and neat. And I want it to be a rigid joint, because I don't want it to be moving. So I'll hit OK. It'll apply. You can see that's our first joint. Now you can keep doing this to make a full chassis. You can put another piece of extrusion along this length, or another piece of channel along this length, as well as along this length. Yeah. Another handy tool in Fusion 360 is with the toolbox. Just by hitting letter S, you have your whole toolbox. So I can start typing in joint, and I can access my joint tool from there as well. A little bit about navigating through your workspace. there's this orbit tool down here. You can change your degree of view. There's also a view cube in the top right, where you can get certain perspectives that you like. And yeah, a pan tool and a zoom tool. So a lot of stuff you can do. Yeah, let's get to something more interesting. So, say we wanted to add a motor, gears, and a wheel. So basic like wheel system to this robot. I'll just do that over here. I'll insert another piece of channel in here, and then I'll move it to the side. And for this one, I want it rotated 180 degrees, so it's on the other side's facing up. 180 degrees. You can also type it in. And let's play around with the other components we have in our bank here. Let's see. Okay, so I want an axle. You can look up axle. Alright, insert into current design. So I want this axle to go through one of the holes here. So the same thing as before, joint. I hit J for that. Joint. I'm going to select the face I want to be joined. So this axle face to, let's try this face here. I can move it along so it's more flush, so it's more natural right there. But I don't want it rigid, I don't want it stuck there, so I'm going to use the revolute joint so it can turn as an axle would as an axle would freely. Okay. But axles don't work like that. They need a bushing to stay in place. So I'll add a bushing. Let's add 2 long bushings. Insert into current design. See that? And then we insert another one. We don't need 2 bushings. There we go. Alright. So joint, hit J. So I want that face to be against that face. But I don't want it like that. I want it flipped. So where it says flip, flip, and there we go. Bushing, just as you'd expect. Is that revolute? Did I make that revolute? Let's see. I can go into the timeline down here and edit the joint to see if I made it revolute. I did. I want it rigid, so it's stuck to the channel. Okay. Let's do the same thing here. J for joint. Select that face. Select this face. And there we go. Oh. Oops, I hit escape too soon. Let's hit J. And J. There we go. Good to go. Okay, so now what we can do is move this axle around in here. But that's no fun, just an axle moving, so let's add a wheel to it. So wheel and insert into current design. There we go, wheel. but the wheel needs an axle hub, right? So I'll leave the wheel there and get an axle hub from my repository of STP files. And here we go at the very top. Insert into current design. And okay. Just like before, joint, J for joint, capture position. That's not the face I wanted. I want, let's zoom in a little bit more. This face, flush with that face. I want it flipped, so I unflip it. There we go, that's perfect. Now I join the axle hub with the shaft, just like you would in real life. It's very intuitive, the software. I want to make sure I get the right face, otherwise the shaded circle goes right there. And then I want to move it down with the arrows. Move it down a little bit. Oop, that's intersecting with the channel, so I'll move it back. I'll just double right click where I see that joint and edit the joint. Oop, wrong joint. Let's go on the timeline. Edit joint. Let's move this farther out. Perfect. There we go. Alright. Let's add gears to this. Alright, so let's take an 80-tooth gear. Those are popular. 80-tooth inserted into this design. I move it here. Why are these joints all becoming revolute? I want these joints to all be rigid. Okay. I need another axle hub. Instead of going back into this bank, I'm just gonna go to this axle hub here. Move/copy, and I'll create a copy of it. Simple as that. I don't want to search for it. Okay. So now in axle hub, I'll just join it just like I did before. J for joint. There we go. That face against this face. And I want it flipped. Okay. And I want to join the actual axle hub to the axle on this side, the opposite side, as the wheel. So J. There we go. And let's move it down. Okay, perfect. Now we want to drive the gear with a motor. Let's go to our motor section of our motor mount, insert into current design, just like usual. These are all over Revolut. I want to change these to. Okay, let's move the motor first. Okay, let's change these back to what they should be, as rigid. Okay. Rigid. This timeline is very helpful, as you can see. It allows you to edit your past actions without messing with the ones you just did. So you can mount them with screws on the bottom, over here and over here. So what I'll do is I'll joint that screw point with, let's see, that one. No. You select the circle. There we go. Flip it. I don't want it revolute, I want it rigid. Let's rotate this 90 degrees. Okay. That looks like a good place for a motor. Okay. Let's insert this motor in here. This is an EndingMark motor that I downloaded this STL file for. So insert in the current design. Alright. Okay. Do a joint here. I'll joint this circle to this circle. Flip, and oh, that doesn't intersect, surprisingly. In real life, this would be a really, really bad design. I'm just kind of making this up as I go. But yeah, don't design anything like this ever. It's kind of, yeah. But basic proof of concept is there. Okay, so we want to mesh a gear. I want to mesh two gears. Looks like a 40 tooth is what we want to go with here. So I have a 40 tooth gear here. Insert into current design. Move it up here. Okay, joint J. Now you should put a motor hub on here, but I'm going to make this quick, so I'll just put it on the wrong way. I want to line these up on the same axis so I can adjust my perspective and get them straight with each other. But, oh no, these are way off from each other. So what to do? Well, as I said, you can go back in your timeline. You can edit the joint you want. So that's the joint I made, positioning the motor mount. So I can go back in the timeline, edit that joint, and instead of placing it over here, I can X out this component and place it over here. And hopefully that'll work. Yep, that's better. Now just intersecting the wheel. Whatever. That can be fixed later. Okay, but it's still not meshing. I don't know. How do we mesh it? Well, you can just adjust this joint right here. Right click, edit joint. And the advantage of these motors is that you can rotate them in the motor mount. That's what I'll do. Rotate it, let's see, 20 degrees to start with. That's meshed. That's not meshed yet. Let's do a little bit more. Edit joint. Let's do 10 more degrees. Nope, a little more. More. Need more. Okay, sure. Yeah, that looks pretty good, I suppose. So, as you can see, I made this joint revolute at the very beginning. So when I spin it, the gears spin on it as well as the wheel. And let's make this joint revolute as well, so the gear spins on the motor shaft. Edit joint, revolute. Sweet. Now, wouldn't it be nice if when I spun, oops, let's escape. When I spun this gear, if this gear would spin as well? Well, there is a way you can do that. First, let's line these gears up so they mesh, kind of. I didn't actually get the meshing right, totally. That looks okay. You can do this using a motion link. Assemble here, motion link, capture position. Select this revolute joint and this revolute joint. And right now it has them spinning at the same frequency. But you want, since this is a 40 tooth gear and this is 80 tooth gear. You want one of them spinning twice as fast, so I'll have 720. That's the wrong gear spinning twice as fast. Let's see, 360, 720. Look at that. There you go. Now you hit OK, and when it spins, they spin together, and they mesh like magic. Yeah, and it's animated and everything. The wheel spins too. Just the problem of this, which I could fix by moving the wheel over here onto this side, but I'm too lazy to do that. Yeah, so that's it for this video. I'm making a simple basics of assembly in Fusion 360 using Tetrix parts. You can use AnyMark has their STP files online, as well as Rev and ServoCity. You can pretty much use anything. Just and the same rules, same principles apply for all of them. Yeah. So thank you. Hope you enjoyed it.